One of the great features of Istio is retries. If one of your pods stops working, Istio can redirect traffic to another pod without the client seeing an impact. In this demo, I will deploy version 3 of our Hello World app. Version 3 will be 2 deployments. We'll have 2 pods in the first deployment and 1 pod in the second deployment. The difference is that the pod in the second deployment will have a pod latency of 5 seconds. So we pass an environment variable to tell our application that it has to wait 5 seconds before executing the code. In our virtual service then, we want a timeout of 10 seconds. So within 10 seconds we need to see a reply, otherwise we just give up on the request. Within those 10 seconds we're going to retry 2 times. So we're going to define 2 retry attempts, and the per retry timeout is 2 seconds. So if a pod doesn't reply within 2 seconds, then Istio will retry using another pod. So our pod latency is 5 seconds, so our Hello v3 will never make it within this retry timeout, and we should only get requests from the first 2 pods. So let's try this out. Let's have a look at Hello World v3.yaml. This is my first deployment. Hello v3 is the name of it. 2 replicas. And I'm just going to echo, hello, this is my pod name, so that I know what pod I'm reaching. This defines my pod name, so it comes from the metadata. This will then just reply the name of the pod. My second deployment is called Hello v3 latency. It's only 1 replica, and it's also going to reply hello, this is and the pod name, but it will introduce a latency of 5 seconds. So this pod will still show text, but only after 5 seconds. We're then going to define a new destination rule or change the current one, and we're going to add v3 to it. We're then going to define a new virtual service, Hello World v3, with the host hello v3 example.com. And this hello v3 will route everything to the v3 version of our pod. So it will route it to the 2 deployments. But we are going to say here, timeout 10 seconds, retries attempts 2, and per try timeout is 2 seconds. Let's apply this. kubectl apply hello world v3.yaml. So this will create 2 new deployments. It will reconfigure our hello destination rule. If you have a look at our destination rule, so we have the hello destination rule. So let's describe this one. So now we have v1, v2, and v3. And then if we do a get on the virtual service, we'll now have a virtual service for Hello World from our previous example, and now we have the Hello World v3. Let's have a look at the pods. These are our v3 pods, Hello World v3, v3, and v3 latency. Let's hit this endpoint. Hello v3 example.com is our host in this case. So this is going to then give us the output. Hello, this is Hello v3 C5. So it's our first deployment, and it's this pod that is replying. We'll need to do it a couple of times. So let's use our for loop again. Hello world v3 for the for loop, and let's also add time. So do time curl. If we do time, then we will see the time that it needs to execute this curl command. Because what's going to happen is that if we first hit this v3 latency, then our request will take 2 seconds longer, because the retry timeout for this pod is 2 seconds. And because this pod only answers after 5 seconds, after 2 seconds, Istio will retry one of those pods. So our time should be a little bit more than 2 seconds if we hit this one. But if we directly hit one of these two, then it should be immediately. So let's execute this and let's look for that result. So here we immediately see it happening. So first of all, we never see this latency pot here. So the only pods that can give us output are the pods from the first deployment. Then if we immediately hit the first deployment, then you see that the real time to execute is very low. You see here and here and here, this 0.0 something. If we hit the latency pod, then you see that there is a 2-second timeout that is added. So for 2 seconds, it tried to get a reply from this pod. It gave up. It went to another pod, which is a pod from the first deployment. And then this replied very fast within less than a second. And this gives us then 2 seconds and just something, where the 2 seconds come from the latency pod and the other time comes from doing the request himself and also the execution of hello v3 and then this pod. If we wouldn't have a retry, we would always have to wait 5 seconds. So I can change the retry or I can remove the retry to show you what would then happen. Hello world v3.yaml. Let's just remove the retry altogether. So I'll just comment it for now. Let's apply this again. Hello world v3.yaml. And now the retry is gone. So what are we going to see now is that we will get requests from our latency pod and it will not be retried, but the latency will be a lot higher. Let's do time curl on this hello v3 host. Hello, this is v3 and this is not a latency pod. This went really quick. Now I do it again and you see now we are waiting. And this is now 5 seconds, more than 5 seconds. And the reply comes from this hello latency pod. So using retries, you can make sure that your requests are retried and routed to a pod that can answer within the retry latency. And this can avoid that an end user has to wait a long time for one pod to respond to its request. If the pod doesn't respond, then it can be retried using another pod that doesn't have this latency, that is maybe not handling as many requests as the other pod, and therefore it can respond much quicker. So this is something very useful to implement if your applications support it.